Welcome back. This is section 9.1 on work, and in your textbook, this is section 8.1. The big idea from this entire chapter is that there can be a change in energy from one type of energy into another type of energy. Energy, we'll see, is the ability to do work, and the work involves moving things and putting them further up in a gravity field or something like that. So we'll look at some examples. I think it's easy to recognize that in order to do anything, like for a car to move or even for you to move, you have to have a source of energy. Energy has to be put into something. You have to have batteries in whatever thing needs batteries. Even your calculator has a solar panel so that you can, so that the light in the room can make it go. Ultimately, the sun is the source of all of the energy that we'll see on the earth, but one type of energy can be converted into another. You can have, say, electrical energy that's put into mechanical energy, or mechanical energy that's derived from food energy, or all kinds of things like this. So you can have a change in energy from one form to another. So the concept of work, work is done on an object when a force is exerted over that object at a distance. So when you move an object a certain distance in the direction of that force, you've done work on it. So if I lift something over my head, whatever distance I've lifted it, I've done work on that object. I've also had to put energy into it, and we're going to see that the concepts of work and energy are very related to each other. So in order to lift something over my head and do work on it, I have to then put energy into it equal to the amount of work done. Because if I were to then drop the object, it would be able to do work as it fell. So it could fall back on my head or whatever and do damage. So as an equation, work is the product of force times the distance. So work is thought of as a force times a distance, or F times D equals work. So like we lift a load against gravity, the heavier the load we lift, the more work we do. So it also has to do with the mass and how hard it is to put a force, because remember, the force is related to the mass. The more massive an object, the more force is required to move it. So if you move it over a distance, the heavier the object you move, the more work you do, and the more energy it takes to do that. Okay, so if Mr. Skinny Man is lifting weights, and I double the weight, okay, so I go from 10 kilograms to 20 kilograms each. I've doubled the weight. Then I've doubled the force it takes to move that mass. And if I've doubled the force, since work, remember, work is equal force times distance. If I double the load, double the mass, then I've doubled the force, and if I've doubled the force, I've doubled the work. So it takes more work to do it. We're going to see then that energy is also related to work, and so the more work that I do, the more energy it takes to do it. So to lift something twice as far, okay, so if I lift the same amount twice the distance, I've doubled the work. Or if I lift it the same distance and double the force, then I've doubled the work. Either case, it's related to the product of force times distance. So we've seen that if I move it twice the distance, okay, so if I move it twice the distance, I've done twice the work. Or if I double the weight up to 20, then I double the work. So since it's a compound of the force times the distance, if I manipulate the force at all, I change the work. And if I manipulate the distance at all, I've changed the work. This is an important point here. Work is not an exertion. So if I were to shove on the wall and push and push and push, or even shove my left hand with my right hand and push and push and push, I could make my muscles tired, and it's possible that I could do work on my muscles. But if I'm not lifting the wall, I'm not doing any work on it. If I hold something out straight and I don't lift it up, then I'm not doing any work on it. So I know that sometimes in the strongman contests, these humongous strong people, one of the tasks they do is just to hold a small battery, like a lawnmower battery, 12 pounds, nothing. They could pull 500 pounds over their head, but to hold 12 pounds for a long time, their muscles are just on fire, because to hold 12 pounds out from your body requires that your muscles be holding on to that. You're still not doing work. You might be getting very, very tired, but you're not doing work on that battery unless you lift it up higher than it was before. Okay, now the concept of work is not always against gravity. Just because I've mentioned a couple times lifting something up, that's an obvious thing of work. But here's a couple other ones. Here's an archer stretching a string back, or pulling back on something that's going to then launch, like a rubber band. So you're pulling back on the string, you're doing work against that string, and then you've stored energy in that string. So we'll see again that work and energy are totally interrelated. They're almost the same, the opposite sides of the same coin. That if you put work into something, now you've got energy stored in it, and that energy can then be used to do something, some other movement. Second example they give here is a pile driver, where if you've ever seen them put signs on the road, or telephone poles, where they're banging something in like a big hammer. So you have to lift the weight up, and then as the weight comes back down, you've stored energy in that pile driver to make it go. Even raising hammers like that, you have to raise the hammer. You've done work on the hammer. Now that you've got energy stored in that hammer, when the hammer falls down on the nail, it can do work on the nail. When you do push-ups, you do work against your own weight. Your weight is forcing you down, and you're pushing up against your weight. Remember, the concept is that force times a distance is equal to work. So if you put a force on an object over a distance, you've done work on it. And so if you've ever changed the speed of an object, in order to change the speed, in order to change the velocity, you have to put force on, or change the force. As you're changing the force on the mass, you're changing the acceleration, which is the velocity over time. You've changed the velocity, and as you're changing the velocity, you've done work on that object. So it takes gasoline to go from 40 miles an hour to 50 miles an hour. You have to burn more fuel in order to change that speed, because you're exerting a force over a distance, and so you've done work on the automobile. So if you remember that work is going to be the product of force times distance, what are the units of force and distance? Force is a Newton, and a distance is a meter. So a Newton times a meter is the units of work, and we're going to name them the joule. The joule, which is a capital J, is going to be equal to a Newton times a meter. We're also going to see that the joule is the unit of energy. How much energy do you have to use is exactly the same amount as the energy used to store it. If I stored energy by doing work on something, then that energy is now available in this. So a joule is also going to be the unit of energy. But right now we'll see that it's a Newton meter, because it's force times mass. So here's a problem. Suppose that you apply a 60 Newton horizontal force to a 32 kilogram package, which pushes it 4 meters across a floor. Okay, so I've got a box. Okay, that box is 32 kilograms. I'm going to exert 60 newtons on that box, and it's going to end up going 4 meters across the floor. So how much work have I done on it? Well, what's my formula for work? Work equals force times distance. So work equals, what's my force? 60 newtons times how far did I move it? 4 meters. So what's my magnitude of my work? 60 times 4 is work equals 240. And what are my units? Newtons times meters. Well, what did I rename Newton meters? Work is equal to 240 joules. So I've done 240 joules of work on that box. So did you learn it? When is the work done on an object? Work is done on an object when you exert a force on that object over a distance in the same direction as the force. So if I put a force on an object and move it through a distance in the same direction as the force. So my force is here, I move an object by that force, and I move it a distance. So here's my distance, here's my force. So if I exert a force over a distance in the same direction, then I've done work on that object.